Hmm. Today I will discuss about machining. In machining process, what we do, we used to remove the extra material to give a accurate dimensional accuracy and as well as good surface finish to the cast part. And regarding the type of turning tools, like a type of cutting tools, we know about the single point cutting tool, double point cutting tool, and multi point cutting tool. Single point cutting tool means cutting takes place by only one edge, and in double point cutting tool, cutting tool is done by two edges of the tool material, like in case of drilling. Likewise, multi point cutting tool means it has many cutting edges, like in case of milling cutter and grinding wheel. These are multi-point cutting tool. Today I'll be teaching you about the single point cutting tool. Mostly that this is the turning process what we use in our day-to-day life. And and first of all, we have to first construct or manufacture the cutting tool, then only we go for the machining operation. And single point cutting tool specifically, uh, turning tool, let me draw this figure. So in turning operations, the workpiece, it's a circular in shape. So I'll be just drawing it. So I'm erasing it again, so I can draw it now. So then then you can see that here I'm drawing one horizontal x-axis line. Then here this is your cylindrical workpiece, and here comes your cutting tool. I think you might have seen. So this is the cutting tool. Okay, you know that your workpiece is being in turning operation. Workpiece is being rotated in your clockwise direction. So I am giving this arrow likewise so that this workpiece is rotating likewise. And this is the edge of the cutting tool. You can see that here and here. Here material is being removed in the form of, that extra material is being removed in the form of chips. Okay, and this is your x-axis, and here it is your from here I am drawing your y-axis. Okay, you can see that the workpiece is rotating in clockwise direction, and this is the cutting tool. So cutting takes place in this direction, in upward direction. So that's why this direction is known as your cutting. So VC stands for your cutting velocity, VC. And here I'm giving, your cutting velocity is likewise along the tangential surface of this circular component. So this is your VC. The VC is your cutting velocity. Okay. And here I'm giving one kind of plane. I think everybody might be heard about this reference plane. I'm giving the symbol pi r. R stands for reference and pi symbol stands for your reference plane, pi r. So this is pi r is the reference plane. Reference plane. So what is now the question comes, what is this reference plane? The reference plane is always the plane which is perpendicular to this velocity vector. Here the velocity vector is likewise, so that's why here along x-axis is your reference plane. That is your reference plane. So that's why it is your pi r. Another term is your gamma. I give symbol gamma. In most of the books, gamma is given for your rake angle. Rake angle. Rake angle. Gamma is your rake angle, and I am giving the symbol alpha. Alpha. Alpha is for your clearance angle. This is about your tool geometry. See this portion, this one, this edge. You can see this edge is known as is the rake surface. Is rake surface of the cutting tool. So that's why this angle is the rake angle. So this is your gamma. So this is your rake angle. This is your gamma. And here you can see that this edge of the cutting tool is the clearance surface of the cutting tool. So the angle, so so the angle it makes, so the you can see that the angle, so I'm getting that point. I missed it. Just wait. I'm now I got this point. Okay. Now you can see that this is the rake surface of the cutting tool. Just for your reference, I'm writing down. This is the rake surface. Rake surface of the cutting tool. What is this rake surface? The surface along which the chip moves upward. That is your rake surface. Okay, you can see that chip is moving upward along this rake surface. That is why it is known as your rake surface. And here, this surface is known as your flank. Flank. What is this flank surface? The other surface which is relieved to avoid rubbing with the machine surface. See, if this angle is not provided, what will happen? There will be the rubbing action of this cutting tool with this machine surface. So would you get the proper surface finish and dimensional accuracy? No. So that's why we used to provide a clearance angle. Clearance angle, if you just draw straight along y-axis. So this is your alpha. This is your alpha. That is your clearance angle. Okay, so what is rake angle? Rake angle is the angle of inclination of the rake surface of the tool from the reference plane. You can see that this is the reference plane. So what is this? What is this rake angle? Rake angle is the angle of inclination, and this is forming an angle of inclination of the rake surface of the cutting tool. This is the rake surface of the cutting tool from the reference plane pi r. That is the rake angle, and it is provided to facilitate machining work. And what is this what is this clearance angle? It is the angle of inclination of the flank surface of the cutting tool from the finished surface, so as to avoid rubbing action between the flank surface of the tool and the machine surface. So this was about the basic nomenclature about the turning operation. And if we draw the tool, I think you might have seen the cutting tool. So if we draw it, so I think you can see that this is the cutting tool. Here we cutting tool, we are using it. This is the shank. This is the body of the tool. This is known as shank, by which we hold the tool. That is the shank. And here, and this surface is known as the top surface is known as your rake surface. This is the rake surface. And here, this is the flank. This is the rake surface. This is the flank surface. And here, and this part, this is the nose. This is, you can see that there is a curvature given here. This is the nose radius, where nose radius we have given for a better surface finish and less tool vibration will be caused. That's why a small radius r is given to the tool nose. This is the nose of the tool. Okay, this is the nose nose of the tool. And here this, you know that there are two cutting edges. One is the principal cutting edge and other is the auxiliary cutting edge. And this edge, this is known as your principal cutting edge, principal cutting edge. Okay, in abbreviated form, I used to write PCE, principal cutting edge. And here, and this is the principal flank, and this surface is the principal flank surface, and this is also flank, but this is the auxiliary flank surface. This is the auxiliary flank surface. So this cutting edge, you can see that two cutting edge. This is the tool nose radius, and we are having two cutting edges. This is the principal cutting edge. This one, and this is the auxiliary cutting edge. Auxiliary cutting edge. Okay. Here but actually the main cutting is done by our principal cutting edge. So that's why it is known as the principal cutting edge. Now, now we can see that in the previous figure, we can see that, so this in this way the tool is being constructed. Here we can add, um, um, in case of tool, in case of tool you can have inserts also. You can place it here and have the cutting operation. Now, dear students, you can see that here, what is this rake angle? Rake angle is here, in this case, it is your positive rake angle. That means you're having some angle. So, rake angle, always remember that rake angles, rake angles, rake angles can be, it can be positive, it can be negative or zero. But clearance angle, it's a very probable question that you should know. It's a general fundamental also. But clearance angle, you can see that clearance angle is all, you can see the clearance angle. If it is negative, means it will be touching the surface of the workpiece. So it won't be doing the good operation. So it is always positive. It cannot be negative or zero. It is always, but clearance angle is always positive. I think by this time you have known that what is the use of the clearance angle. Clearance angle is provided so that the workpiece is relieved from there is a space between the finished surface and the cutting tool flank surface. So it can never be negative, it can only be positive. But the rake angles can be positive, negative, or zero. So in this figure, you can see that rake angle is positive. Rake angle is positive means you can see that this rake angle is something, some value there. So positive rake angle, when the rake angle is positive means you can see that if you gradually increase the rake angle, what will happen? Your tool strength will gradually decrease because your tool will be become thinner and thinner. You can see that if you increase this gamma means your tool will be very thin. Gradually it will be very thin. If you reduce it likewise, the tool becomes very thin. The strength of the tool decreases, as well as its heat conduction capacity also decreases. And if you increase the strength of the stool means, if you're that is the positive rake angle. And in case of if the rake angle is very large, that means that I've told you that if gamma is very large, very large, that means your tool will become thin. Tool will become thin, and it will lose its strength. Okay, so what will happen? In order to increase the strength of the tool, we used to provide a negative rake. How the negative rake angle is being provided, you see here likewise. So negative rake means you're providing the rake angle is like this. You can see that here in this case, this is the condition of positive rake, and this is the condition of negative rake. Negative rake angle means you're strengthening the tool and heat conduction capacity. And mostly this negative rake angle is used when tool material is very brittle, such as carbide or ceramic tools. And it is used in high speed cutting operation. When you require for machining at very high speed, that time you use negative tool. Then third one is a case, it is a positive rake, it is a negative rake, and third case is our zero rake. Zero rake means, so it always works, it is rotating in clockwise fashion. First condition. First condition, second condition, and third condition. Third condition, that is zero rake. Zero rake means you can see that this is the condition of your zero rake angle. That means your gamma is equal to zero. This is used in case, this is the simplest kind of tool and mostly used for making the form tool. In later on subsequent classes, you will be knowing the form tool. So it's simple in construction, but it obstructs the movement of chip flow and causes build-up edge formation. You can know that you can see that in case of positive rake, there is a space that the chip may move upward. Chips means the extra pieces of the worksheet that is being removed by machining process. It has to be cleaned from the surface, otherwise it will stick to the machine surface and retard its finished structure. So, but in case of when the rake angle is zero, means it obstructs the movement of the chip flow and causes build-up edge formation. In case of chips morphology, we can really knowing the term build-up edge formation means it will be sticking to the machine surface. So that is not at all desirable. So it was all about your tool nomenclature. And so what is the shank? What is shank? Shank is the main body of the tool. And what is flank surface? The surface below and adjacent to the cutting edges. You can say that these are the cutting edges and these are the surfaces below the cutting edges. What is rake surface? The surface along which the chip moves upward. That is your rake surface. And what is nose? This is your nose. It is the point where the side cutting edge, that means the principal cutting edge as well as auxiliary cutting edge meets or intersects. And this is the principal cutting edge. It is formed. What is this principal cutting edge? Principal cutting edge, it is formed by the intersection of your rake surface and the principal flank surface. What is auxiliary cutting edge? This is the auxiliary cutting edge. It is formed, the section or the edge which is formed by the intersection of the rake surface and the auxiliary flank. So this was all about your tools. Now we will go to the tool tool reference system. That means the type of reference system for tool geometry. First of all, we need that tool has to be constructed. Then only it can be used for machining operations. So we will go to the American Standard System. That is your ASA system. So systems, first of all, machine reference system, or it is also known as your ASA, American Standard System. American Standard System. Okay. So, and by this ASA system, we used to construct the tool. So let me draw the figure first. Second is our ORS system, orthogonal rake system. That is your okay. First of all, we'll go to the ASA system. This is the cylindrical workpiece. This is the single point cutting tool. This is pi r reference plane. I think I have already told you what is pi r. Pi r is the plane which is perpendicular to the velocity vector. And this is the rake surface. And this edge is your auxiliary cutting edge. And this section is the principal cutting edge. The principal cutting edge used to be bigger in length as compared to the auxiliary cutting edge. And here, if we take any section, X and we'll cut it along X and Y axis. So this is the same thing here. This is XM axis. This is YM, and this plane is pi x plane. This plane is pi x plane, and this plane is pi y plane. I'll explain what are all these terms. Okay, you know that what is first of all, first term is our pi r plane. What is this pi r, a reference plane? The plane which is perpendicular to velocity vector vc. That is your pi r plane. Then what is pi x plane? Here in ASA system you can see three kinds of planes: pi r, pi x, and pi y plane. And pi x is known as your machine longitudinal plane. Machine longitudinal along the length. Machine longitudinal plane. You can see that it is along the length of the workpiece, so it is a machine longitudinal plane pi x. And what is pi x? Pi x is the plane perpendicular to pi r plane. This is plane perpendicular to pi r plane, and in the direction of longitudinal feet. Okay, that is your pi x. So you can see that this is the plane perpendicular to pi r plane and in the direction of your longitudinal feet. Third plane is your pi y plane. What is this plane? This plane is known as machine transverse plane. Machine transverse plane. Machine transverse plane. And what it is? The plane which is perpendicular to both. What it is? Plane perpendicular to pi r and pi x plane. And pi x planes and in the direction of your transverse feed. In the direction of your transverse feed. And in the direction of transverse feed. That is your pi r, pi x, and pi y plane. Then directions, you can see that xm, ym, and zm. So let me explain these directions. Axis in reference system. What is the first one? First one is your xm. What is xm? In the direction, this is the direction. Xm is the axis of the machine tool, longitudinal axis of the machine tool, or in the direction of xm is in the direction of longitudinal feed. Okay. Or longitudinal axis of the machine tool. Second, YM. What is YM? It is in the direction of transverse feed. Y-axis transverse feed along Y-axis. That is along Y-axis. Okay. Third is ZM. ZM is in the direction of where velocity VC will be there. There will be the ZM. Always remember this. In the direction of velocity vector VC. Where there will be velocity, there your axis will be ZM. Okay, it always follows your right hand thumb rule. Okay, now we will see the geometrical parameters of single point cutting tool. There's of single point cutting tool in ASA system, American Standard System. In ASA system, we have to remember this sequence of nomenclature. First one, always remember that the first term comes is your back rake. Just I'm getting the cursor. First one is the back rake. Remember the sequence: back rake, side rake, side rake, end clearance. These are back clearance angle, side clearance angle, end clearance angle, then side clearance angle, then end or auxiliary cutting edge angle. Then sixth one is the approach angle, APPROACH, approach angle or lead angle. So these are the six angles, and seventh one is the nose radius. And in case of ASA system, nose radius is always in inches. Remember it. Okay, now we'll go to the symbol. I think I've told you what is the symbol of rake angle. Rake angle is always gamma, and back rake is denoted by gamma y. Side rake angle is denoted by gamma. Side rake is denoted by side means x, back means y. End clearance angle, you know, clearance angle is also known as relief angle. So it is denoted by alpha. So end clearance angle is denoted by alpha y, and side clearance angle is denoted by your alpha. Side means x, end or back means your y. So this is your alpha y and alpha x. End cutting edge angle is denoted by your phi c, phi c. Approach angle is denoted by your phi f. And nose is in radial. So now what we get it, sequences, remember that gamma y, gamma x, alpha y, alpha x, phi c, phi f, and r. This is the nomenclature of your ASA system. If you know this, if you remember this sequence, so whenever problem is given to you can get the data. What is the value of your gamma y, gamma x? What is the value of your phi, that is auxiliary cutting edge angle, and r? So you can get it. So now we will draw the figure where to locate all these angles. I think these angles have to be placed on the tool so that it can be cut as per this angle so that we can manufacture the cutting tool. Okay, this is the x-axis we have constructed, and this is the cutting tool. Likewise, and this is the nose radius. So I'm giving a little curvature r, small r, and here this is the reference plane pi r, the plane perpendicular to the velocity vector. Okay, now this is the xm axis, this is your xm axis, and this is your pi x plane. Pi x plane, what is pi x plane? The plane perpendicular to the pi r plane, and it is along in the direction of your longitudinal feet, that is your pi x plane. And here this, what about this one will be your ym axis, and this one will be your pi y plane, the plane perpendicular to both pi x and pi r planes, and in the direction of transverse field. Okay. And what is this? This is the principal cutting edge. This is the principal cutting edge. So principal cutting edge. So this angle here we are getting one angle. This angle is our phi s. That is the lead angle or approach angle. That is your phi s. And here this is the auxiliary cutting edge. This is the auxiliary cutting edge, you know that auxiliary cutting edge. And here if we draw horizontally one parallel line along the x-axis, you're getting one this angle. So this angle is known as your auxiliary cutting edge angle or end cutting edge angle, that is your phi c. So you can see that 5 6 angles means your auxiliary cutting edge angle here, and your approach angle or lead angle phi s we have already drawn, and r is the nose radius, we have already drawn this three. Fifth, sixth, seventh. Now we have to place 1 2 3 4, that is back rake, side rake, and clearance, and side clearance angles. Okay, so this is done. This is the this is the principal cutting edge, PCE, principal cutting edge. And what is this? This edge is your auxiliary cutting edge, auxiliary cutting edge. Okay. Now what we will do? We will cut the section of the tool by pi x plane. Cut the section, cut the section of the tool by by pi x plane, pi x plane. So what we will get? This is the pi x plane. So So now when you cut any section of the tool, it's a 3D view imagination. When you cut any section of the plane tool by suppose pi x or pi y plane, then pi r, this pi r plane will be replaced by that plane. So here pi r is being replaced by your pi x plane, and here a pi x plane, and here this axis is your xm, and this is, and it was earlier, this was your pi x plane. Now this will be your pi r plane. This is pi r plane, and this is your vc. Vc is equal to in the direction is always your zm. Zm axis is always in the direction of your cutting velocity vc. And this is the rake surface. This is the rake surface of the tool. This is the rake surface of the tool. Okay. And so this angle will be your gamma stands for your as this is the angle made by the rake surface of the tool. So this symbol will be obviously it is a rake angle, that is a gamma, and it is made by the pi x plane. So this is your gamma x, and this angle will be your alpha x, that is the clearance angle. Clearance angle, that is alpha x, is the side clearance angle. It is along the x axis. So this, and here this one is the pi y plane as usual. Pi y plane, this is the pi x plane, this is the pi r plane. Now again we will cut the, we have already cut the section of the tool by pi x plane. Now we cut the section of the tool, cut the section of the tool by pi y plane. Pi y plane. So we are cutting it along y axis or pi y plane. So this plane will be pi y, and where it was pi y, that will be our pi x, pi r plane. This is, earlier it was your pi y plane. Now pi y will be the pi r plane, and pi r will be the pi x plane. So, and this is the rake surface of the tool. This is the rake surface, and this is the flank surface. So this is ym. This is pi x plane. This is pi x plane. This is them along the velocity vector. Now, now, so we have this angle rake surface means it's this angle. What will be this angle? This angle is equal to rake angle means as it is enclosed in the rake surface, it is your gamma y, and it is your alpha clearance angle alpha y. Here always it is a rake angle, and other side will be the clearance angle. As I've already taught you in the very beginning of the figure, you can see that here one side it is the rake angle, one side it is the rake angle, and other side will be the clearance angle. So here we have got it. Okay. Now we will define. So we have drawn all the angles: back rake, side rake, end clearance, side clearance, and cutting edge angle, approach angle, and nose radius as well. Now we will define each and every angle. So what is the first one? The first one is the back rake. Number one, back rake. Back rake, rake angle. Back rake is always denoted by your gamma stands for your rake angle. In 90% of the books, rake angle symbol is given by gamma. Back rake, gamma y. So now I think you can define what is back rake. So let's go to the figure. Gamma y. What is back rake? It is the angle of inclination of the rake surface of the tool from the reference. You can see that what is this plane? This plane is the reference plane. Angle of inclination of the rake surface of the tool from the reference plane, and it is measured along pi y plane. So that is your rake surface. That is the angle of inclination, the angle of inclination of the rake surface of the cutting tool. Rake surface of the cutting tool. Angle of inclination of the rake surface of the cutting tool from the reference plane. What is the reference plane? You can see that reference plane is here. It is your pi r. This is the reference plane. From the reference plane pi r and measured along and measured along. We have cut this section of the tool along which plane? Along pi y plane we have cut it and measured along pi y plane. Unless and until we cut it by pi y plane, we cannot able to get the back rake, isn't it? So that's why it is measured along pi y plane. And number two next, this is about back rake. Then side rake. Side rake is given by gamma, and side rake means that means your gamma x. Let's go to the figure and we can define side rake gamma x. Angle of inclination of the rake surface of the cutting tool from the reference plane but measured along pi x plane. Earlier pi, what is gamma y? What is gamma y? It was the same thing but it was measured along pi y plane. Side rake is the same as the angle of inclination of the rake surface of the cutting tool from the pi r plane. You can see that rake surface of the tool from the pi r plane, but it is measured along pi x plane. That is the only difference. The angle of inclination of the rake surface of the cutting tool from the pi r plane and measured along pi x plane. Here it was only pi y plane. That is your side rake. Third one is the back clearance or end clearance angle. Back or end clearance angle. Clearance angle, as you know, denoted by your alpha, and back symbol means your y, alpha y. So we will go to the figure and see what is alpha y. Here you can see alpha y. So alpha y, it is the angle of inclination of the flank surface or the principal flank surface of the cutting tool from the, this plane is your from the pi x plane. You can see that this plane is the pi x plane and measured along pi y plane. I think it's very clear. Angle of inclination of the flank surface of the cutting tool from the pi x plane and measured along pi y plane. Angle of inclination of the flank surface of the cutting tool. Of the flank surface. Of the surface of the cutting tool from the pi x plane. From the pi x plane. I'm enclosing within the circle for your understanding only, from the pi x plane and measured along pi y plane. If you have understood, if you can draw the figure properly, you can define all the angles by yourself. And fourth one is your side clearance angle. Side clearance angle, that is your alpha. Clearance angle is your alpha, and side clearance angle, it is your x. We will go to the figure alpha x. Where is the alpha x? Alpha x. What is alpha x? It is the angle of inclination of the principal flank surface of the cutting tool. From this one is what is from the pi y plane and measured along pi x plane. Angle of inclination of the principal flank from the pi y plane and measured along pi x plane. Okay, so it's gone. Then fifth one is your end cutting edge angle phi c. End cutting edge angle, that is phi c. What is, we can define, this is the auxiliary cutting edge angle. So angle of inclination of the auxiliary cutting edge from the, what is this plane? This is the pi x plane. From the pi x plane and measured along pi r plane. Angle of inclination, angle of inclination of the auxiliary cutting edge, auxiliary cutting edge from the pi x plane, from the pi x plane and measured along pi y plane. That is your end cutting edge angle. Next, sixth one is your approach angle or the lead angle. Approach angle or lead angle. Lead angle, that is your phi s. It is the angle of inclination, angle of inclination, angle of inclination of the principal cutting edge from pi y plane, from pi y plane and measured along pi r plane. Let's see approach angle. This is your approach angle. This is the principal cutting edge. So it is the angle of inclination of the principal cutting edge from the, what is this y x? Y plane is your pi y plane, from the pi y plane and measured along pi r plane. So these are all the terms. And 7 is the nose radius. Nose radius. Nose radius are in inches. ASA, we used to adopt inches. So these are the nomenclature. Now I would like to insert one tool diagram. Now you can see, now we have constructed the tool. Okay, okay. Okay, you can see that this is a tool. Tool we have manufactured. Then you can see that all whatever the angles we have defined, you can see here and here. This is the tool nose radius. This is the back rake. This is the back rake. This is the side rake. This is the side cutting edge angle. This is the side clearance angle. This is the flank surface. This is the face of the tool. This is the end cutting edge angle. So all this is the axis, this is the end clearance angle. So here you can see that all these six angles you can see in this figure. So I think every now this ASA system it is very much clear to you all, um, which is used for making the tool. So I stop here. In my next video I will be explaining you about the ORS system.